Hey, sixth grade, we are on page 256. We've done this entire page except number 10. Okay, so we're just going to backtrack right here and do number 10. A triangle has a base labeled B that is 6 inches. The area of the triangle with the height representing, eighth representing the height, is given base times height divided by 2. Complete the table to show how the area of the triangle changes with its height. So if your base is 6 and your height is 4, 6 times 4 is 24. Divide that by 2, you get 12, right? Your base is 6. If your height is 5, 6 times 5 is 30. Split it in half. You get 15. 6 times 6 is 36. Split it in half. 18. 6 times 7, 42. Split it in half. 21. 6 times 8, 48. Split it in half. 24. How does the area change as the height increases? Why does this happen? Well, each time area increases by 3 inches, and technically 3 inches squared. I don't know if I can do my little cube thing, but 3 inches, what square inches? 3 square inches for every inch increase of the height. Okay, why do you think this is? Well, our base is 6, but we do base times height and then divide it by 2. So when your base is 6, the base is 6, but you later divide by 2. I'm going to put /2, but in writing, I'm going to put the division sign, but you later divide by 2. So really, we're always taking the height times half of the base, or in this case, it would be the height times 3, or 3 times the height. Just want us to see those little patterns and things. Okay, on to page 257, number 15. Bill and Tia are trying to evaluate the expression 5x squared when x equals 3. They both agree that 3 should be substituted for x. Yes. Tia says, then we multiply 3 by 5. So I like to have this written out, and since I can't do my exponent, I'm going to just write it out. 3, 5, 3, and squared. Okay. Tia says next you multiply 5 by 3, you get 15, then you square the result. Bill says we should square the 3 first and then multiply that by 5. Who is correct and why? Then it says what is the value of the expression. So Bill is correct because he followed PEMDAS, but okay, PEMDAS says exponents before multiplying. Okay. And then we solve it here. So 5 times 3 squared. 3 squared is 3 times 3. Okay. And we really end up with 5 times 9, which we know is 45. So 45, do we have to label it? Nope. It's just, okay. Just the answer, 45. 16, some STEM connection. I always have this amazing thought that I'm like, oh, I'm just going to memorize, Fahrenheit to Celsius conversions. And I never have it down. I just sometimes know approximations. I know that 100 degrees Celsius is the boiling point of water, which is the same as 212 degrees Fahrenheit. I know that 0 degrees Celsius is the same as the freezing point of water, which is 32 degrees Fahrenheit. Anyway, so the expression F minus 32, and then you take that times 5/9, gives the temperature in degrees Celsius for the Fahrenheit that's given. Okay, find the temperature in degrees Celsius that's equivalent to 77 degrees Fahrenheit. So all of this lesson, you guys, like this entire module, it's all about plugging in for the formula, right? So 77 minus 32 is 45. Okay, so you have 45, and we have to take that times 5/9. I'm going to make this a better looking fraction for you. And that we know is 45 over 1. Okay, I would cross cancel. We're multiplying these. I would cross cancel if possible, and it is possible. 4 plus 5 is 9. So I know that I can divide both of these by 9. Okay. That becomes a 1. This becomes a 5, and we end up with 5 times 5, which is a nice, easy peasy 25, and then little, again, I don't know how to do that. Maybe there's a way on here, but anyway, degrees Celsius. Okay, so I would have the little degree symbol in front of that, 25 degrees Celsius. Water freezes at 32 degrees Fahrenheit. At what temperature does water freeze in degrees Celsius? If you were listening a bit earlier, maybe you would recall it is 0 degrees Celsius, and we can totally plug it in if we want. So we get 32 minus 32, 5/9 of that. Well, 32 minus 32 is 0. So you have 0 times a fraction. Anything times 0 is 0. And there you have it. 17. To find approximately how many pounds are equivalent to a given number of kilograms, use the expression 2.2K. We've been doing this, right, with our conversions and stuff where K represents kilograms. How many pounds are equivalent to 6.5 kilograms? So again, we plug it in. So 2.2 times the K, which is 6.5. Punch it in your calculator. And let me double check here what it says in the calculator. I don't think you can see this, but 6.5 times 2.2. And oh, good. Okay. I thought maybe we had to do some rounding. So we get 14.3. And I believe our label here is pounds. Okay, 18. To find the perimeter of a regular octagon, stop sign shape, use the expression 8s, so 8 times each side length. If the length of a regular octagon is 1.5 feet, what is the perimeter in feet? Okay, so we've got 8 sides times 1.5 each. Just punch it in your calculator there, and we end up with 12 feet, where some of you would like to do like 8 times 1 is 8. Half of 8 is 4. 8 plus 4, still get there, 12. Again, my favorite thing about math is getting to see how your brains work by solving all these cool problems. So there's your nerd factor for today. Number 19, a rectangle is twice as long as it is wide. If the width is W, then that would make the length 2W. The area of the rectangle can be found using the expression 2W squared. If the rectangle is 10 centimeters wide, what is the area in square centimeters? All right, plugging it all in here. So 2W, and then a little 2 for squared. Okay, if the rectangle is 10 centimeters wide, so we've got 2 times 10, and we need to square it. Okay, we need to square it first. So we've got 2 times, and then 10 squared is 10 times itself, which ends up being 2 times 100, wait, oopsie, equals 200, I believe it's centimeters squared, or square centimeters, centimeters with a 2, it's all the same. Okay. For problems 20 through 25, I highly suggest you pause the video, just punch it in the calculator. I mean, it's for the decimal ones anyway, or your exponent ones. And then for your fraction ones, it takes a little more brain work, but it's not too bad. Okay, 6W and W equals 0.1. So again, it's the whole setup here. 6 times 0.1. Well, you can do this mentally. 6 times 1 is 6. You've got 1 behind the decimal, so 6/10 is our answer for number 20. Okay. This one, something plus 5.25. Oh, whoopsie. Okay, I thought that was more complicated than it is. Sorry. So we have 3.5 plus 5.25. I am going to try to be smart about my space here and do times 2 times 2 to make them into fourths. So it's 5 1/4. Pardon my attempts here. 5 1/4 plus 3 2/4. 5 plus 3 is 8. 1 plus 2 is 3. And we've got fourths. So 8 3/4 for number 21. Number 22, 1.4y indicates multiplying. So 1.4 times y, which is 5. 1 times 5 is 5. 0.4 is going to be more, so your answer should be higher than 5. Punch it in your calculator. We get a 7 there. Okay. 23, 48 divided by k, and k equals 3. 8 plus 4 is 12. You can divide 12 by 3, so it's going to be divisible evenly. That's a trick you can do with 3s and 9s. If you can add the digits together and get a sum that's divisible by 3 or 9, it works perfectly. So you can work it out the long way if you want. You can punch it in your calculator if you want. 3 goes into 4 once. Take away 3, 1 left. 3 goes into 18 6 times. We have 16 there. Number 24, z to the 5th power, and z equals 2. So you've got 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 13. Oh, excuse me. Oh, my word. I said something silly. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I might have said 13 last time. Sorry, 16. 16 times 2 would be your 5th power. Double the 16, you get 32. Okay. Number 25, 2.5 times g squared. So here you've got 2.5 times 4, and the 4 is squared. Pardon my giant exponent here. Exponents first. So we end up with 2.5 times 4, which is 16. Punch it in your calculator, right? 16 times 2.5 is 40. Not too bad. Okay. Last page here for our lessons. To evaluate the expression r plus 6 squared for r equals 7, Saeed says r should be squared and 6 should be squared, and then the results should be added. Explain why Saeed is incorrect. Then find the value of the expression when r is 7. Okay, well, there's so many different ways you can solve these problems incorrectly, right? And again, so this is why mathematicians got together and said, whoa, we need to figure this out because we are getting 8 different answers that all seem to make sense. Enter PEMDAS, okay? Parentheses, exponents, multiply and divide left to right, add and subtract left to right, okay? He says you square the r, then you square the 6, then you add them together. Why is he incorrect? So following PEMDAS, you do parentheses first, okay? Then you do your exponent in this case. Now, some of you are probably wondering, just to glance back here on the last page, like, wait a minute, Mrs. Top, we had 2.5 times g squared here. Why did we do our exponent first? Because there weren't any parentheses to be doing. And sometimes we just have to be very cognizant of this. So very aware, pay attention. Sometimes there are parentheses like around the 2.5 or something, but they're not like normal parentheses. They're just asking us to multiply, and it just depends how the problem is and the way it looks. Okay. So if that isn't wonderfully confusing, anyway, okay. So r plus 6 squared. R is 7 plus 6, and we're going to square it. Okay, 7 plus 6 is 13. And we end up doing 13 squared, 13 times itself. Well, 12 times 12 is 144. 13 times itself is going to be higher. I believe when you do 13 times 13, we get 169 as our answer. And if we had done it Saeed's way, let's see, we would have gotten 49 plus 36. I don't even know, right? Which is 85. Very different answer. Okay, so hang in there, you guys. It just takes lots of practice. And I will admit, I love algebra. So this stuff is so exciting for me, but I understand how scary it can be right away. So just hang in there, and I believe in you. It will be okay. All right. For a squared, they tell us a equals 6. We're going to square it. And then we're taking away minus b over 6. B is 36. Have that over 6. Right, I'm going to draw my little fraction bar here. Okay, so we want to do parentheses. This parenthesis tells us we're multiplying stuff together. So really we skip on to our exponent piece. Okay, so this becomes 4 times 6 times 6, 36. Okay, minus 36 over 6. Now, whoopsie. We're multiplying here, we're subtracting there, we're dividing here. So now we multiply and divide left to right. 4 times 36, I don't expect you to know it. Enter it, okay. 144 minus 36 divided by 6 is 6. 144 minus 6 equals 138. Beautiful. Number 28. Rosa sells pens. She pays 75 cents for each pen and sells them for $1.25. She uses the expression 125 times P minus 75 cents, essentially, times P, where P is the number of pens she sells to calculate her profit. If Rosa sells 48 pens, what is her profit? Okay, so we're going to just plug in P for pen, right? So 1.25 times the 48 and take away the 0.75 times the 48. So computers and calculators are great. You have to make sure you're entering things correctly or this will be quite a flop. Anyway, 1.25, 8, I get 60 there. Okay, so what are we doing in here? We got 60, take away, oh my goodness, one of my children is screaming right now. And someone is here watching them, but it does not sound good. Goofed up. Okay, sorry, got a little distracted. 60, take away 36. And I kind of like to work backwards here. What is her profit? We're dealing with money. Add 4 to get to 40, 20 more to get up to 60. $24 is what she earns from selling 48 pens. And if you want to divide 28 by 20 or 48 by 24, she earns $2 for every pen she sells. Right. 29, almost done. Steve is playing a carnival game. He wants to win a prize, but he thinks he has about a 20% chance of winning. So that's 1 out of 5. If he plays 5 times, one of those times he's hoping to win. He uses the expression 2/10 of t to calculate the number of games he can expect to win if he plays a certain amount of times. If he plays 12 games, how many times can he expect to win? Different ways to solve this. Personally, I would do 0.2 or 20% times 12. So 0.2, 0.20. Okay, I hope I'm setting this up right. 0.2 is 12. 2, yep. So we get 2.4 when you calculate it, but 2.4 times, which ends up being like he's not going to play 4/10 of a time. They wouldn't sell him a ticket for that, right? So we'll say about 2 times or about twice if you'd rather write it that way. Okay, last stretch here. Problems 30 through 35 evaluate the expression s cubed for the given value. So every single time we're going to cube it. So we're constantly going back to this little section right here, but they're giving us a different value for s. Okay, beauty of the calculator, you guys. S is 4. 4 times 4 times 4. 4 times 4 is 16. 16 times 4, 64. Here we've got 3/10. Be careful with your decimals, right? Your decimal place gets a little bit funky. So 3 times 3 is 9. You have 2 behind the decimal, so that'd be 9/100. 9 times 3 is 27. And now that shifts back to the thousands. So 0.027, calculate it. It's all good. 1.2, I know 12 times itself is 144. 2 behind the decimal, so 1.44. 1.44 times 1.2 ends up being 1.728. And that is what will come, yeah. So that's the entire answer. Like you've got 3 behind the digit. If you've got 10 behind the digit, feel free to go up to like the 100th place or something. I know some of these weird answers, you guys get nervous. You're like, wait, Mrs. Top, do I put 1.7 or 1.73 or what do I do? This is short enough. Just enter what's on your calculator there. Okay, that's all good. I'm going to skip the fractions for now and just do the simple number 33. 10 cubed, 10 times 10 is 100, times 10 again gives us 1,000. Here's a tip for the tens, and you can even use this to tackle some IXL. When you're taking 10 times itself, all you're doing is adding a 0, right? So like 10 times 10 is 100. So 2 zeros there, right? And if you do 100 times 10, now you've got 3 zeros, just like it was in your problem. So the little exponent, if you're just dealing with 10, gives away how many zeros are in your answer. Okay. Now, 31, 35, I have to actually type these out. So we've got 1/2 times 1/2 times 1/2. Okay. And here's the beauty of it though. We can multiply straight across. 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. So 1/2 cubed is really 1/8. Okay. Here, 1/6, I'm going to type it so it's nicer for you. 1 times 1, what do you know it? It's going to be a 1 over 6 times 6 is 36. I don't remember what 36 times 6 is. I have to calculate it. 2/16. So this one ends up being 1 2/16. Okay. There you have it. Way to hang in there, you guys. I miss you when I'm just virtual here. And I mean, I'm sure you're just fine without me, but I miss the little like questions or thoughts or just different ways you guys solve problems. Um, anyway, I appreciate you hanging in there and working with me virtually. Just want to let you know it's not the same, but thank you for having a good attitude and getting this done. Carry on.